Hey guys, welcome to lesson 11, right angle trigonometry, solving angles. So learning goals today, I can use triangle trigonometry and the idea of inverse operations to find missing angles in right triangles. And I can use trigonometry along with Pythagorean theorem to solve a right triangle. So basically the difference between this lesson and what we did on lesson 10 is on lesson 10 we found sides, and on this lesson we're going to find angles. Okay, so this question says, our first example here, solve for angle theta. Okay, and we know two sides. So like I said, always when you're doing a triangle like this, you want to label your sides first. So you label it based on the angle you're looking for. So well, first of all, across from the right angle is your hypotenuse, right? And then across from the angle you're looking for is going to be opposite, and your last side is going to be adjacent. Okay? Now we pick which ratio to use. So it's SOHCAHTOA. This is what we should be memorizing, SOHCAHTOA. And we need to use opposite because we know that side. We also need to know hypotenuse because we know that side. We want to use two sides that we already know. And opposite and hypotenuse is sine, right? Sine is opposite and hypotenuse. So over here we can solve for this. So it's sine theta equals opposite over hypotenuse. Okay. And then we can plug in what we know. So it's sine theta. We don't know the angle, so we leave it as theta, equals opposite is 6, and hypotenuse is 11. Okay? And now we need to get theta by itself, but these ratios are special. You can't like divide both sides by sine, because sine has to have like a number that goes along with it. So in order to get rid of sine and get theta by itself over here, we have to do what's called the sine inverse on both sides. So it's sine, but with a little exponent of -1. So we sine inverse both sides. So it's sine with a little -1. And I'm going to rewrite this so you can see what I mean. So when we sine inverse over here, it gets rid of the sine. So you can think of these canceling out. So we're just left with theta equals the sine inverse of, you want to put it in brackets, this fraction, 6 over 11. So it's the sine inverse of 6 over 11. Okay. And then we have theta equals, and then at this point we want to put it in the calculator. So on this calculator, first of all, make sure it's in degrees. This one says D at the top there, so it is in degrees. And then we are doing inverse sine. So you do shift sine. So you can see a little sign with a -1 there. And in brackets, you do 6 divided by 11. Okay, and then equals, and we got 33 degrees. We can just leave it as 33 degrees, and that is our answer. Okay. If you're using a different calculator, one that if you type in sine, like you can't see it. Okay, if you're using a calculator like that, you're going to want to do 6 divided by 11 first, hit equals, then do shift sine, and then you'll get your answer that way. Okay, so it kind of depends on which calculator you're using. That way works for this calculator as well. Okay. Okay, now most of these are going to be similar steps to what we just did. So again, always labeling our triangle first. Across from the right angle is our hypotenuse. Across from the angle we're looking for is opposite. And our last side is adjacent. Okay. This one we know adjacent and we know hypotenuse, right? 9 and 13. So we want to use both of those. Okay. Cosine uses adjacent and hypotenuse, so we're going to use cosine. So it's cos theta equals 9 over 13. 9 over 13. Okay, because it's adjacent over hypotenuse. And then we do the inverse cos on both sides. So cos with a little -1, cos with -1. And again, I'll rewrite it just so we can get used to it. So these coses you can think of canceling. We're left with theta equals the cos inverse of 9/13. And when we take that in our calculator, we will get the answer. So again, we do shift cos. In brackets, we put our fraction, so 9/13, 9 divided by 13. Close the bracket and hit equals. We get 46 degrees. Okay, for these ones, I'm not going to do decimal places when we're finding an angle. Sometimes I will specify, so just make sure you're looking at the question to see. Okay, next one. We have our angle here. So opposite that angle is opposite. Okay, usually we would label hypotenuse first. That's across from the right angle, so that's hypotenuse. And their last side is adjacent. Okay, and as you can see here, we know hypotenuse, we know adjacent, so we want to use cos again. Okay, so we have cos theta equals adjacent 34 over hypotenuse, which is 39. Okay, and then theta equals cos inverse of 34 over 39. Okay, so I didn't show like what I had in red here, but that's what we're doing. We're taking the cos inverse of both sides. It cancels the cos on the left-hand side, and then we have the cos inverse of this fraction on the right-hand side. Okay, so that's the cos inverse of 34 over 39. Now we plug this into our calculator, and we'll get our answer for theta. So the shift cos of 34 over 39 in brackets, and we get 29 degrees here. 29 degrees. Okay. Something I forgot to mention, if you look at your calculator here, the reason we're hitting shift and then cos, it's not in focus here, but in this yellow writing, you can see the cos inverse button. So when you hit shift, that uses the yellow buttons on top, and that's why we get our cos inverse. Okay. Okay, next one says determine the measure of angle A. Okay, so we have angle A right here, and we're trying to find what that is. You can leave it as being called angle A, and I'll show you. We're just gonna, instead of writing theta, we'll just write A, capital A. And I will say, when we're labeling a triangle, we usually label the angles as capitals, and then the side across from it is small letter. So if this is angle A, this is small a. If this is angle C, this is small c. If this is angle B, then this is small b. Doesn't really matter in this question, but in the future, it will be important. Okay, so if we're labeling based on angle A, again, across from the right angle is hypotenuse. And then across from the angle we're looking for is our opposite. And then our last one is adjacent. Okay. And here we know opposite, we know adjacent. So we want to use the ratio that uses opposite and adjacent, which is tan. Okay. So we have tan, and this time we're calling our angle A. So we can do tan of capital A equals, and it's opposite over adjacent. Opposite is 8, adjacent is 6. So it's 8 over 6. Okay. And then we tan inverse both sides. That gets rid of the tan on the left. And we take the tan inverse of the other side, 8 over 6. And we have that A equals the inverse tan of 8 over 6. So shift inverse tan in brackets 8 divided by 6. and we get 53 degrees. So angle A is 53 degrees, and that question is done. Okay, now we can move on to the back side. I think we're going to start solving triangles on the back here. Yes. So this is important. If I ever ask you to solve a triangle, okay, if I ask you to solve a triangle, it says to solve a triangle means to find all missing sides and angles. So you need to find everything, okay? So in this case, we know 34 degrees, we know 18, but that is it, okay? So you have to use that information to find the other sides and angles. If you remember, you might have done this before. All angles in a triangle always add to 180 degrees, okay? So if we add angle A and angle B and angle C, then it should equal 180. So let me just show you that here. So angle A plus angle B plus angle C, anytime you have a triangle, if you add up all the angles, it equals 90 degrees. Okay, we know angle C, and it doesn't tell us angle B, but we can see it's a right angle, right, which is 90 degrees. So we don't know angle A, so we'll leave it as A. We know angle B is 90. Oh, I messed this up. Sorry. All angles add up to 180, not 90. All angles add up to 180. Hopefully you caught that. I wrote that down wrong. Okay, so angle B was 90, and angle C is 34. That equals 180. And then if we solve this, so we'll get that A equals 180 minus 90 minus 34, right? If you just take away 90 from both sides and take away 34 from both sides, we'll get that angle A is, so 180 minus 90 minus 34 is 56. Okay, so we have our first angle is 56 degrees, angle A. So this is 56 degrees. Okay. And now we just have to find these two sides. Okay. So we're going to start by labeling this triangle in order to find the sides. And you want to label it based on the angle that was given, just in case you made a mistake with this angle. If you use the angle that was given, then you'll probably get it right. Okay, so across from the right angle, again, hypotenuse. Across from the angle we're looking at here is opposite. And then our last one here is adjacent. Okay, so this is back to finding sides, right? So we know this angle, and if we want to find this, let's start by finding this side across from it, so our opposite side. And like I said in the last page, we label our sides. Our sides are small letters across from the angle. So if this is capital C, then this is small c. If this is big B, this is small b, and then this is little a. Okay? So again, we want to find C, so we're using opposite, and we know adjacent, so we need to use adjacent. Okay? Opposite and adjacent is tan, so we have the tan of 34, right? Tan of this angle here equals opposite over adjacent. So opposite is C. We don't know it yet, so we leave it as C. And then adjacent is 18, so it's C over 18. Okay, so we're left with this. Again, if I'm going too quick, pause the video if you need to, and you can rewind it or go back to have a re-explanation. Here when you get C by itself, so if you multiply both sides by 18, you'll get C by itself, because here we're multiplying by 18 but also dividing by 18, so those are going to cancel. And we have that, so now we have C by itself. We have C by itself, and that's going to equal 18 times tan 34. So in this calculator, you can just do 18 times tan 34, just the way it's written. And we get 12.1 for a side. I will do 1 decimal place. So 12.1, and this is in centimeters. Okay, so we should box these. So we know angle A is 56. We now know C is 12.1. Okay, so if you want, you can write over here as well that this is 12.1. And the only thing left we have to find is B, okay? And we can find B using Pythagorean theorem. Okay, so to find B, so remember when you're doing Pythagorean theorem, there's different versions of how you write it, but all that matters is that your hypotenuse is the one that's by itself, okay? So if we look at this, this is B, this is C, this is A. Our hypotenuse is B. So B squared is going to be by itself on this equation. And then C and A are going to be on the other side. Okay, so A squared plus C squared. So I know this looks kind of different than maybe what you guys are used to, but all that matters is that this is the hypotenuse, and then your other two sides are on the other side of the equal sign. So these two sides squared equals this side squared, right? Okay, so let's plug in what we know. So B squared equals, so A is 18, so 18 squared, plus C is 12.1, so 12.1 squared. So B squared is going to equal, so 18 squared plus 12.1 squared. That's 470.41. And then to get B by itself, we need to square root both sides. So B will be the square root of this number. So square root equals 21.6, or if you round it, 21.7 centimeters. Okay, so we were missing an angle and two sides, and now we found that angle and two sides, so we have solved the triangle. I might ask you to put this in a chart, and all I mean by putting this in a chart is whatever angles you find. So if you have angle A, you know it's 56 degrees. C is 12.1 centimeters, and B is 21.7 centimeters. So if I ask you to give your answer in a chart, this is all I mean, is just give me a nice boxed solution here with everything that you found, all your final answers, okay? Okay, on the last example, similar to that one, we're just gonna solve this triangle. We have different letters here. So let's start by just labeling it with the letters. So if this is angle M, across from it is small m, okay? This is angle V, across from that is small v. And then if this is angle D, across from that is small d. Okay? And now we can label based on this angle that we know. So across from the right angle is hypotenuse. Across from the angle we know is opposite. There's a lot of labeling here, so we just want to make sure we're staying consistent so we don't get confused, right? So we have opposite, we have hypotenuse, and then our last side is adjacent. Okay? Now, first thing we should find is this angle here, because that's the easiest thing to do. So because these angles all have to add to 180, you could just do 180 minus these two angles, and you'll get what V is. So capital V is going to equal 180 minus our two angles, so minus 51 minus 90, right? Our two angles are 51 degrees and 90 degrees. Okay. And if we do this, 180 minus 51 minus 90, should get 39 degrees. Okay, So capital V, angle V is 39 degrees. Okay. And then just remember, we labeled this triangle based on the 51 degrees, right? Because opposite is across from it. So when we do our equation, we have to use that 51 degrees. And it's our choice if we want to solve for opposite, or if we want to solve for adjacent or hypotenuse. Yeah, it doesn't really matter here. Let's just solve for adjacent. So if we solve for adjacent, we know opposite, so we need to use opposite and we need to use adjacent. Opposite and adjacent is tan again, all right? So tan of the angle, so tan 51 equals opposite, which is 14, over adjacent, which is small v. Okay, right? Adjacent is small v, opposite is 14. So that's how we get this equation. Now remember, if the variable is in the denominator here, we need to get out of the denominator. So we multiply both sides by v. Okay. When we do that, these v's cancel. So we're left with v times tan 51 equals 14. And then to get v by itself, we can divide by this whole tan 51. Okay. When you do that, the tans cancel. And we have v equals 14 divided by tan 51. Let's put that into our calculator now. 14 divided by tan 51. We get 11.3. And since this is a side, we can do one decimal place, 11.3. And there's no units here, so we can just leave it with no units. Okay. And just, I want to point this out. When we're dividing by the whole tan 51, we can divide. We only do the inverse tan if we're finding an angle. Only if we're finding an angle. Here we're finding a side, so we can just straight up divide tan 51 by tan 51, and that's totally fine. Okay, and finally, Pythagorean theorem to find our last side. The last side we're trying to find is the hypotenuse, and that's called m. So remember, our hypotenuse goes by itself, our hypotenuse squared, so m squared equals our two other sides, so d squared and v squared. So d squared plus v squared. Okay, so this is our formula for Pythagorean theorem. M squared, which is the hypotenuse, equals d squared plus v squared. And then we know d is 14, and we know v is 11.3. We just found that. So we have 14 squared plus v is 11.3 squared. Okay, m squared equals this. And then we need to find what this equals. Okay, so 14 squared plus 11.3 squared equals that. And then we know we're going to square root this to get the m by itself, right? So we can just square root this right away. Okay, and it's 18. So m is going to equal 18. Okay, and then if you want to give me a nice little chart here, so we found capital V first was 39 degrees. We found small v is 11.3, and we found that small m is 18. So that is the missing sides and angles that we found. Okay, that is the lesson. You guys start working on the practice, and we will prepare for the quiz tomorrow. Don't forget to check your solutions on the back. Have fun.